Here we're asked to express the following complex numbers in trigonometric form. The first thing we're going to do for each one of these is draw a picture of what this complex number looks like in the complex plane. So the complex plane starts off with a vertical and a horizontal axis. We find -2 on the horizontal axis and then down 2 on the imaginary axis, and now this point down here is the point -2 minus 2i. So to describe this using trig form, we need to find the radius, or r, that is the distance from the center, which is the origin, to the point -2, -2, which we can find using a distance formula. So r is -2 squared plus -2 squared, the x-coordinate squared, the y-coordinate squared, or the real part squared and the imaginary part squared. Add together, take the square root, and we get the square root of 8. Or if you want to be really nice and fancy, we can reduce that to 2 radical 2. The second part in this problem is to figure out what this angle is here. But we know that's just pi over 4 more than pi, so the angle is 5 pi over 4. So we can write this complex number as being 2 radical 2 kiss 5 pi over 4, where kiss is just a shorthand for cosine of 5 pi over 4 plus I sine of 5 pi over 4. For the second one, we're going to do the same thing. Draw a picture, radical 3, which is larger than 1. 1 is here, and so there's our point. We're going to find this radius. R is going to be the square root of 3 squared plus 1 squared. So we get 3 plus 1. Square root of that is 2. And then this angle here is a nice pi over 6 measured angle. So the trig form for radical 3 plus I is 2 kiss pi over 6. And for the last one, this one's a little bit different because there is no real part to it. It's just an imaginary part. So you can think of this as being 0 minus 6i. So it's 0 along the horizontal axis and then down 6. So this point right there is -6i. And as we can see, the radius is going to be 6. That's how far that point is away from the origin. And the angle is 3 pi over 2. So -6i is 6 kiss 3 pi over 2.